So next one, we're moving on to Korea. We have Dr. Taeyoung, who serves as the Director of Supercomputing Infra Center at KISTI. So he will give us an overview of the HPC landscape in Korea and what's happening with the KISTI-6.
Hello, everyone. My name is Taeyoung. I'm from KISTI. I'm Director of Supercomputing Infrastructure Center. Right now, I'm presenting the overview of KISTI National Supercomputer Center and the upcoming KISTI-6 machine. Before going into detail, I want to briefly mention the landscape of HPC AI infrastructure in Korea. Actually, the Korea government designated KISTI as National Supercomputing Center in 2011, and based on the Supercomputing Promotion Act, and to initiate and lead development national HPC ecosystem. And then 2022, they also designated 7 application domain center as tier 1. And last year, the Korean government changed. The new government promoted large-scale AI projects. And so, for example, they tried to make the development of the sovereign foundation model, strengthening the utilization of AI computing resource, and the establishment of National AI Computing Center. So, for example, the National AI Computing Resource Project driven by NIPA, they already installed 13,000 GPU system. Last year, they invested $1 billion. They also tried to make another big system. It will consist of 10,000 GPU machine, which consist of B300 and Vera Rubin. This project is going on, so maybe our machine will be ready for early next year. And also, they want to try to make another big AI computing center. It will make 15,000 GPU machine. But this model is PPP based, so some private sector company will be joined. And there are a lot of activities on tier 1 centers. So, for example, the KMA, I think they will restart their K6 machine this year after acquiring the additional budget. And KISTI as a National Supercomputing Center providing high-performance computing resource and dedicated backbone research network. And since 1988, we deployed the Cray2S, Korea first supercomputer, and then we periodically upgraded our machine in line with the HPC trends, such as back to SMPP and right now the MPP machine. So currently, our machine is called Nurion. It put in production in 2018, and it provides 25 petaflops. It consists of 8,300 compute nodes, and it also has 20 petabyte scratch. And that machine also have 0.8 petabyte burst buffer. That solution, we think it can be used for the I/O acceleration, but we found that that system is used too hard because user have to manually do file sync and file staging before and after launching a job. So, but anyway, maybe this year, second half this year, this machine will be decommissioned, and it already enabled more than 60 million jobs run, and its utilization rate about 77%. So through support of over more than 200 projects annually, we supported more than 1,300 high-level SCI papers and about 6 years. And to complement our basic, our CPU-based machine, we install this small size of GPU machine, but that machine is annually upgraded based on the needs from users and benchmark for next generation hardware. So it did much focused on the support AIDL training and GPU accelerated HPC applications. And from the about 6 years experience about the operation, we think we have some very good information to learn and to prepare the next generation hardware system. KISTI-6, this project is restarted last year after 2 years delay. The delay is heavily due to the ChatGPT boom and spike of the GPU price in 2023. So May last year, the contract made. From the early this year, the deployment is started, and file system already installed. And right now, we almost finished the hardware installation. So we entered into the system bring up stage. So we are doing right now the triage and replace the faulty hardware components. So if everything goes well, I think we'll run our benchmark software, and then we'll have some stability tests and functional tests, and then second half, I think we put the machine in production service. Interesting thing is that the whole machine is direct liquid cooling based, so we think liquid to air cool ratio can be 96:4. So its PUE we expect about 1.1 or something. Each compute nodes have 4 GH200 chips, where ARM CPUs and NVIDIA GPUs tightly integrated high bandwidth NVLink and with the support of cache coherency unified memory. So due to those kind of fact, we expect the performance of the machine will be a little bit higher than the typical x86 and H100 architecture. We are now considering the NVIDIA's core scheduling to assign separate CPU-intensive workloads a large portion of the ARM CPU cores, while GPU-intensive tasks being executed or GPUs on small portion of CPU cores. And as for interconnect, one of the key requirements we consider is we want to maintain system the non-blocking across all layers. And so the system configuration right now, the injection local global network bandwidth is 1 to 1 to 1. And system organized into island groups. So each island group has 104 GPU blades. And our system is fully connected. And this architecture is the Dragonfly topology. So adaptive lighting should be properly working under congestion or case where no minimal routing is needed. As for storage, we focused on the automatic tiering between 21 petabytes NVMe and about 180 HDD, so to support IO-intensive workloads. So pre-control access file remains in high bandwidth storage area, while the cold data that is automatically migrated to cold hard disk area. And we want to provide all compute nodes for batch job-based learning and interactive workloads. So HPC simulation or AI training will be done batch job, and HPC and AI code development and debugging and profiling will be done interactive workload. And we expect right now the HPC AI workload ratio is about 70 to 30, and we a wide range of courses in material science and nanotech biofields are and AI run on GPU partition, while traditional workloads should be covered by the CPU partition. And we developed the Kubernetes-based web service portal, KISTI, provides cloud service application such as VS Code and RStudio and so on. We also implemented KHPC gateway to all these kind of the web-based application to be launched transparently on normal compute nodes once the resource have been allocated by the typical HPC scheduler slump. Okay, that's all my.
Thank you. Thank you, Taeyoung.